This is the interim presentation for analysis and redesign of a handheld spreader by Team 15. To use a handheld manual spreader, the user fills the hopper with material to spread across a lawn or a garden. Then the user spins the handle wheel to turn the gears attached to the spreading wheel. These spreaders are easy to use and robust, plus they are very portable. This is an exploded view of all the components of the handheld spreader.
The spreader's primary customers are individuals and families who maintain personal properties with lawns and gardens. These customers will minimally use their spreader, using it for routine maintenance. The product's secondary customers are service providers, such as landscapers, who maintain multiple properties a day. Both the primary and secondary customers require the spreader to be durable and reliable. It should be easy enough to use for a casual user and a frequent user to utilize, and withstand a wide range of usage types.
For the functional analysis, the task function of our product is distribute product. The basic functions that achieve this task function are project product, disperse product, and contain product. To assure dependability, the product will prevent clogs and leakage. To assure convenience, the product will control flow. To enhance product, the product will stop flow, and to have multi-material compatibility. For please senses, the product is lightweight, balanced, and comfortable.
We have two proposed assembly sequences shown in the two fishbone diagrams below. On the left is the first assembly sequence, which is a top-up approach. Starting with the base, we install the three separate gears, followed by the spreading wheel and the handle body support outer. Next, we install the handle subassembly, which includes the handle body support inner, the handle, and the handle cap. Next, we install the handle lower subassembly, which includes the handle lower and the feed control, followed by the hopper to give us the seed spreader assembly sequence 1. The second assembly sequence is a top-down approach. First, we start with the hopper, followed by the installation of the handle lower subassembly, which includes the spreading wheel, the feed control, the handle lower, and the third gear. Next is the base subassembly, which includes the base, second gear, first gear, and handle body support outer. Next, we install the handle subassembly, which includes the handle body support inner, handle, and handle cap, which gives us the seed spreader assembly 2. Assembly Sequence 1, the bottom-up assembly, was determined to be the preferred method of assembly, with Sequence 1 outweighing Sequence 2 in nearly all key criterion.
This slide presents our functional component mapping matrix, which we use to identify how each part of the handheld seed spreader contributes to the overall product functions. As shown, multiple parts combine to perform key roles. For example, parts 2, 9, 10, 11, and 12 all work together to form the functional handle, which operates to achieve assured convenience and please senses by improving comfort and ease of use for the user. The spreading wheel, on the other hand, is critical for achieving uniform product distribution. We also emphasize multifunctional components like the flow gate, which directly influence both product release and flow rate. This mapping process allowed us to see how each component supports multiple functions, minimize redundancy, and prioritize improvements in high-impact areas. Overall, it guided our design towards a more efficient, reliable, and user-friendly seed spreader.
The bill of material is composed of 13 unique parts, with one standard component being screws. The majority of the components are made from polypropylene and are injection molded. The three gears are manufactured from 1117 steel and our CNC machine from bar stock. The material, assembly, and tool costs for each components are shown in the table, and the total cost of manufacturing is $24.39 compared to products on the market, which is $22, which is an 11% increase to competitor products.
This slide shows how we use a functional differentiation table to guide the design of our handheld seed spreader. We focus on keeping core functions like spread product, project product, and the rest shown on the table the same across all models, while customizing features shown as feed control, contain product, and handle ergonomics for different users. This approach allowed us to balance shared efficiency with tailored usability, ensuring each design feels purposely built without adding unnecessary complexity.
Three components are different in the spreader between the two customer groups. These components are the hopper body, feed control, and the handle cap. The hopper body will be larger for the secondary customer group. The feed control will either be basic or advanced, providing more slot opening options for the feeder. And the handle cap will either be simple or have an ergonomic design, which also allows the user to provide more force when turning. Here we can see the design changes between those three components. The hopper body is larger for the secondary customer group, allowing the user to spread more product and reach a larger area. The feeder control either has one opening for simple usage or 3 openings to assist with the flow of products and adjust to the product size, whether it be fertilizer, seed, salt, etc. The handle cap either is simple, just going on the end of the handle present, or as there is an ergonomic handle cap, which will benefit those who are continuously using the spreader. Here we can see the exploded view of the product for the secondary customer group. You can see that the hopper body, feed control, and handle cap are all highlighted in red, showing where the differentiation is between the primary and secondary customer groups.
The original assembly sequence yields what we deem to be the most efficient assembly sequence when also factoring additional variants. Delaying assembly of the variant parts like the handle cap, feed control, and hopper body yield the most efficient use of time and cost, all while mitigating overall assembly complexity.